Assalamu alaikum wa rahmatullahi wa barakatuhu. Welcome back to the correction of the midterm model exam part 2. So in this part, inshallah, we will do the correction of the question number 4. Question number 4 has two questions. So the first question will be, what is the mass of 602 10 power 23 molecules of chlorine gas? This question is the inverse of the question number 3, which we corrected in the first part of this recording video. So here, what I got as information here, he gave me the number of the molecules, and he asked me what is the mass of this number of molecules. Right. In this situation, he gave me the number of molecules and he asked to convert it to mass. So what I will use? I will use the molar mass. Means I will need to convert this number of molecules to number of moles. So what is the relation between the number of moles and the number of particles? Now, what is the number of particles? In my case here in chemistry, I do have either atoms or molecules. Here he was specifically, why he gave me here the number of molecules? Previously in question number 3, it was the number of atoms. Alhamdulillah. So here why he gave me molecules, because I do have a chlorine gas. And the chemical formula of chlorine gas is Cl2. So I have to use molecules, not atoms. So now I have two methods. Either I convert number of molecules to moles, and then I convert moles to masses using the molar mass of a chlorine gas. So first thing, I need to convert the number of molecules to moles. If I do some attention, few seconds of attention, he gave me this number. And what is this number? This number is Avogadro number. 602 10 power 23. So 602 10 power 23 molecules have 1 mole of chlorine gas, because it is Avogadro number. Right. We do it step clearly. So here what I know, that 1 mole of chlorine gas has 602 10 powered 23 molecules of chlorine gas. How many molecules I do have here? I do have here 602 10 powered 23 molecules of chlorine will be X, and X will be equal 1 mole. Because it is the same number. So why I wrote for you this relationship? You see, this is the key relationship. Now I suppose he didn't give me 602 10 power 23 molecules. Yes, he can give me any number, and just I have to write this number here and to convert the number of moles. Type. Now I got the number of moles. So what is the mass of 1 mole of chlorine gas? What is the mass of 1 mole of chlorine gas? Will be equal what? The number of moles multiplied by the molar mass of a chlorine gas. So the molar mass of a chlorine gas will be equal to multiplied by 35.5 multiplied by 1 mole. So this one will be equal what? 71 gram. So this is the mass of this Avogadro number of molecules. Why here I multiplied by 2? Because I do have a chlorine gas 2. The periodic table I will get only 35.5. Type good. This one is the first question. Now how about the second question? So now we'll look for this problem solving in chemistry, because if we don't solve this kind of problems in chemistry, means we did not do chemistry and we don't learn chemistry. طيب, now, when 17 grams of oxygen gas are reacted with 32 grams of ammonia NH3 according to the above reaction. Sorry, here it will be according to the above equation. Because we know that the chemical equation is the translation of the chemical reaction. Now he asked me what? Here he asked me, I reacted to reactant. So here it will be what? It will be a limiting reactant problem. So means I have to specify which one is my limiting reactant. And this limiting reactant will limit the amount of the formed product. صح أم لا؟ طيب, now, before I do any calculation, I have to be sure that my chemical equation is balanced. Here, Jazallahu khairan, he gave me the balanced chemical equation. But let's say we do it together, inshallah, to find how we do the chemical equation. So this will be the first question. Balance the chemical equation. صح أم لا? We do it together, inshallah. Because some students, they do have difficulties how to balance this equation. So A, it will be balance the chemical equation. So I will do it now. Always when I do a chemical equation, it is easy to start with the element that I can find only in one molecule, in one reactant and in one product. Here I can use either nitrogen or hydrogen. Why I cannot use oxygen? Because it is in two products. It will make difficult the balancing. So I will start with nitrogen. Here I have one nitrogen, here I have one nitrogen, is balanced. Type now, how many hydrogen I have here? I have 3. And here how many? 2.5. So I have to multiply by 1.5 or by 3 over 2. صح أم لا? I have to multiply by 1 over 5, 1.5. Now, how many atoms of oxygen I have here? I have 1.5 plus 1, 2.5. And here I have only 2. By which value I multiply? I multiply by 125. I multiply by 125. Type. Oh, hang on, doctor. For balancing a chemical equation, I should have a whole number or an integer. So how I convert here 1.5 and 1.25 to a whole number or to an integer? One of your friends will tell me, doctor, I have to multiply by 2 here. Yes, you multiply 2 by here. All I have to multiply by 2. Correct. But here what I will get? I will get 2.25. 2.5. And here I will get 3. So what I will do? I will multiply again by 2. So means what here? I multiply all by 4. I multiply all the reaction by 4. 4 multiplied by 1.25 will give me 5. And 4 multiplied by 1.5 will give me 3. Oh, sorry, will give me 6. So we do it. So this is my balanced chemical equation. 4NH3 plus 5O2 will produce 4NO plus 6H2O. Now I balanced my chemical equation. To be sure, let's check. 4 nitrogen, 4 nitrogen, 4 multiplied by 3, 12. So here I have 12 hydrogen. How many oxygen I have here? I have 4 plus 6, 10, and 5 multiplied by 2, 10. So this is my chemical equation, my balanced chemical equation. So now, be careful. When I write a chemical equation, is not as just for writing, just for fill the blank, not as hashu or abath. No, it has to be used. How I will use this one? Because he asked me, determine the limiting reactant. Determine the limiting reactant. حدد العامل المحدد. By definition, the limiting reactant is the reactant that is consumed first. And you have seen this one in the first part, in the false and the true questions. So the limiting reactant is not the product, it is the reactant that is produced first. And how I know? So since here I have two reactant, here I have, he gave me the amount of two reactant, I have to calculate for each reactant what is the amount of the product is formed, and the limiting reactant will be the reactant that produces the lesser amount of the product. So this is what I have in my mind. Now, doctor, I do have two products, nitrogen monoxide and water. So which one I will use as a product to make my calculation and to see which reactant will give me the lesser amount of the product? So here I have to see what is the question. This big question, the second question, he asked me how many grams of water are produced. So here what I will focus, I will use the amount of water produced. And like that, I will hit two birds with one stone. I will determine the limiting reactant and the amount of water produced at the same time. And I answer my question. Type here, to solve this problem, I have two methods, either the moles method or the gram method, which we call the rabbit method. Why we call it rabbit? Because all of you know the turtle and the rabbit story. So the rabbit is the quick method, not to waste a lot of time. But the turtle wasted a lot of time and she won the race. The race, sorry, not the rice, the race. Type. So in this case, I have to convert number of grams to number of moles, then using my chemical equation, then using the conversion factor of my chemical equation to find the number of moles. And since he asked me how many grams of moles, so I need to convert number of moles of water to grams of water. See, 4 or 5 steps. So the rabbit will use the first starting point as the turtle. So he will use the chemical equation. So from my chemical equation, I suppose that the ammonia is the limiting reactant. And the question mark, I don't know. So how I do it? So what does it mean if I suppose ammonia is the limiting reactant? It means I will use all the amount of ammonia reacted with the oxygen. So from my chemical equation, I have 4 moles of ammonia produce 6 moles of water. Since I got here the masses of the reactant in gram, so what I will do, the rabbit will convert this relationship in moles to masses using the molar mass of the compound. So means here what? That 4 moles. What is the mass of 4 moles of ammonia? Will be 4 multiplied by 17 grams of ammonia. From where we got 17 grams, the molar mass of ammonia will be equal 14. The molar mass of nitrogen plus 3 times the molar mass of hydrogen will give me 17 grams. produces 6 multiplied by what is the molar mass of water? 18 gram. How it comes 18 gram? I have oxygen 16 gram plus 2 times multiplied by 1 for hydrogen will give me 18 grams. 6 multiplied by 18 grams of water. This one I will convert. Easy. 17 multiplied by 4, 68 gram of ammonia produces 108 gram of water. صح ولا لا؟ Just I multiply 6 multiplied by 80. Now how many grams of ammonia I react or I completely consumed? It is 32 grams. 32 grams of ammonia will produce X gram. So how I can find X gram is the cross product. ضارب الوسطيين يساوي ضارب الطرفين. So X will be equal 32 multiplied by 108 divided by 68. So simple. And this one 32 is close to half of 68. So my amount will be above 50. So the calculator will give me 32 multiplied by 108 divided by 68. And I will get, so this one will be 32 multiplied by 108 divided by 68 equal 50.8 grams or 50.9 grams. So it is 50.8 grams. So this is the amount. This is the mass of water produced if I consumed all the ammonia. Can I say that the ammonia is the limiting reactant? No, because I have to compare two values. So what will be the second value? The second value will be what is the mass of water produces if all the oxygen is consumed. So the second step, I will ask the question, O2 is the limiting reactant. And the question mark, because I don't know. So the same, I read from my chemical equation. From my chemical equation, it tells me that 5 moles of oxygen gas produces 6 moles of water. So here will be, from my chemical equation, 5 moles of oxygen gas produces 6 moles of water. Now things are getting easy. Why? Because I will convert the moles to grams. So what is the mass of 5 moles of oxygen gas? Be careful, here I have oxygen gas. It's not 16, it will be 32. So I have here 5 multiplied by 16 multiplied by 2. And I will get 160 grams. 160 grams of oxygen gas produce. What is the mass of 6 moles of water? I have already done it. So it will be 108 grams of water. This is from my balanced chemical equation. However, did I react 160 grams? No, I react 17 grams from the information it was given to me. 17 grams of O2 oxygen, it is here. See, it is here, 17 grams. So 17 grams of oxygen, how many grams of water will it produce? X gram, and X gram will be cross product. So 108 multiplied by 17 divided by 160 gram. And this one will give me 17 multiplied by 108 divided by 160. And this one will give me 11.47.5, about 11.5 gram of water. So now I will compare the two masses of water produced. So here I have 11.5 and here I have 15.8. So which reactant have produced which reactant has produced the lesser amount of water? Is it oxygen gas or ammonia? Oxygen gas. So Oxygen gas is my limiting reactant. This is the answer. O2 is the limiting reactant. This is now the official answer. Oxygen gas is the limiting reactant. And how many grams of water are produced? Automatically 11.5 grams of water are produced from this one. And I hit here 2 birds with 1 stone. ضربت عصفورين بحجرة. So I identify my limiting reactant. I identify what? The amount of water. كفى المؤمنين القتال. So this is the answer of my question. So simple. Of course, this method is the simple method, as I told you, but it will depend what your teacher has taught you for this type of problems. But it will be based on the same conclusion, which reactant will produce the lesser amount of the product. Either it could be in moles or it could be in masses. طيب, now we'll add another question. So since the oxygen gas is the limiting reactant, what does it mean? It means I have completely used the 17 grams of oxygen gas. How about ammonia? So ammonia gas is an excess. عندي فائض من غاز الأمونيا. What is the mass of the ammonia remained after the reaction? So since is in excess, so I cannot use completely. صح أم لا? Because I have used it already the nitrogen, the oxygen gas, which is my limiting reactant. So this one will be in excess. So how many grams are left, or how many grams are remained after the reaction? To find it, how many grams of ammonia are remained, first of all, I have to find what? How many grams of ammonia were used or are used? How many grams of ammonia are used? So once I find it, how many grams of ammonia are used, just I make the subtraction between this value and what I have put in the beginning, 32 grams. So now the problem will be how many grams of ammonia I have consumed or I have used. Always think about that when you write a chemical equation, you will use it. It's not for abath or for hashu, not just for filling the blanks and just for playing. No, you have to use it. So from my chemical equation, how I can read now this chemical equation? It's getting bigger. How I can read this chemical equation from my balanced chemical equation? That what? 4 moles of ammonia. So means to consume 4 moles of ammonia, I need 5 moles of oxygen from this part of the reaction, from this part of the equation, sorry. So 5 moles of oxygen require 4 moles of ammonia. Or to consume completely 4 moles of ammonia, I need 5 moles of oxygen. Or to use completely 5 moles of oxygen, I need 4 moles of ammonia from my equation. So you see, you have A equal B, so either you can use the number of the product or the mass of the reactant. You have 2 ways to solve this problem. Since they are reactants, so I will use the relationship between the reactant. So from my chemical equation, I have 4 moles of ammonia require 5 moles of water. Sorry, of oxygen gas, because water is part of the product, so it's not a part of the reactant. So the same here. I will use the same method of the previously. I will use the rabbit method. That means here I will convert the mass, the mole, to masses. What is the masses of 4 moles of ammonia? I have already did it. صح أم لا? So this one is 68 grams of ammonia. So simple. What is the masses of 5 moles, of oxygen gas? So it is 160 grams. I did this one previously. Since the oxygen gas is the limiting reactant, means I consumed all the 17 grams of oxygen gas. What is the mass of ammonia required? The mass of ammonia required will be X for this reaction, and X will be equal 68 multiplied by 17 divided by 160, which is the cross product. And this one will be equal 7.2 grams of ammonia. Means what here? To consume, to react all the 17 grams, means to consume all my limiting reactant, oxygen gas 17 grams, I need 7.2 grams of ammonia. I put in my reaction 32 grams, so I have an excess of ammonia. So what will be this excess value? So this is how many grams of ammonia are used, and now will be 32 grams, the starting mass of the ammonia, minus the consumed gram of ammonia, 7.25 grams, and this one will give me 24.8 grams. And this is the mass of ammonia remained after the reaction or have been left after the reaction. Before I conclude this problem, so if you like to make my life a little bit difficult, so in which sense? He will ask me, so here I find the mass of water. If he likes to ask me how many grams now of nitrogen monoxide are produced, without doing any calculation. So, without doing any calculation before I close this problem. How many grams? These are additional questions. How many grams of nitrogen monoxide are produced? So the normal student, he will say what? Since the oxygen gas is the limiting reactant, so I will use my chemical equation. 5 moles of oxygen gas produces 4 moles of nitrogen monoxide. This is from my chemical equation. 5 moles of oxygen gas produces 4 moles of nitrogen monoxide, and I will do the calculation. Normal, simple. It's a good way, but there is an easy way to do it, a simple way to do it. Just within 2 seconds, think about the law of conservation of mass. So what does it mean, the law of conservation of mass? Means the mass of the products will be equal to the masses of the reactant. Here, mass of O2 gas plus mass of NH3 will be equal mass of nitrogen monoxide plus mass of water. Be careful here. Here is the mass of the oxygen gas consumed and is the mass of ammonia consumed, not the mass of ammonia which I put in my reaction. So the mass of oxygen gas is 17 grams, plus what is the mass of ammonia consumed is 7.2 grams, will be equal to what? X is the mass of nitrogen monoxide plus 11.5 grams of water. I have already did it before, and for this I take my conclusion. make my conclusion that the oxygen gas is the limiting reactant. So this one 17.2, 17 plus 7.2 equal minus 11.5 and will give me 12.7 gram, and X is simple mathematical equation, 12.7 gram of nitrogen monoxide. You see in 1 minute. In 1 minute. This is how I use the mass of conservation, the molar mass of conservation. Sorry, the law of the conservation of mass. There is no law of conservation of the number of moles. Yalla, doctor, to be sure that what I did is correct. So from my chemical, so this is the first method. The second method told me that 5 moles of oxygen gas produces 4 moles of nitrogen monoxide from my chemical equation. So I will use the rabbit method. I convert the number of moles to masses. This is 160 gram of O2 gas. Will produce, mashallah, now we are professional. What is the molar mass of nitrogen monoxide? Will be 14 plus 16. 14 plus 16, 30 grams, means here will give me 120 grams of NO. How many grams of oxygen I consume it completely? It is the limiting reactant oxygen, 17 grams. And 17 grams of oxygen gas will produce X mole of nitrogen monoxide. And X will be 17 multiplied by 120 divided by 160. I got it, 12.75. X is 12.75 gram, which is close to 12.7 grams. You see, so here we summarize what we have seen in chapter number 3. So I hope that this recording video, part 1 and part 2, is useful, and everything I said true comes from Allah, and if some said something wrong, it comes from myself. So I wish you good luck, and سبحانك اللهم وبحمدك نشهد أن لا إله إلا أنت نستغفرك ونتوب إليك. Please do not make dua, or I do that for you. Allah will help you inshallah, and يوفقكم في الاختبار. والسلام عليكم ورحمة الله وبركاته.